Hello, and welcome to the SQL Server Maintenance and Performance Essentials webinar presented by Don Jones. I'm Christina Bartz from TrainSignal, and I'd like to take a minute to tell you what to expect in the next hour. First, I'd like to draw your attention to the questions box in the webinar control panel. Don will be answering questions today, so feel free to submit your questions during the presentation. Also, if you have any technical difficulties, let us know in the questions box, and we'll do our best to assist you. Today's presentation will be recorded and available to view on our blog. We'll email you the link after the presentation. After you exit the webinar, you'll be prompted to take a short survey. TrainSignal wants to hear from you, so please take a few minutes to complete the survey. We'll also be choosing one participant from today's audience to receive a copy of TrainSignal's SQL Server 2008 Administration Video Training. To be eligible to win, you must complete the survey that you will receive after the webinar. Be sure to fill it out. It only takes a few seconds. If you have additional comments or feedback, you can email us at webinars@trainsignal.com. And with that, thank you for joining us for today's webinar. Here's Don.
Hello, and let me also extend my welcome. Today we're going to be talking about SQL Server Performance and Maintenance Essentials. So let's dive in. As we do so, I want to invite you again to add your questions to our question queue. I will be taking those as we go, so there's no need to save them up until the end of the broadcast. Let's get those questions out of the way and get you some answers. So today we're going to be looking at some of the under-the-hood processes that SQL Server uses to actually accomplish what it does, and focus on how those processes affect some key maintenance and performance tasks that, as administrators, we're responsible for completing. Now, this isn't intended to be a comprehensive look at every little piece of maintenance you might need to do in SQL Server, but it is a look at some of the things you'll do most commonly, and a look at some of the things that most people tend to find the most confusing. So hopefully we can clear up some of the confusion, get it out of the way, and get you on the right track toward making SQL Server a better maintained and better performing part of your environment. Just a brief introduction. My name is Don Jones. I'm a Microsoft MVP Award recipient and a VMware vExpert Award recipient. My full-time job is as a senior partner and principal technologist at Concentrated Technology. We're a boutique IT consulting and education firm. I've written more than 50 books about various IT-related topics, and I'm a monthly columnist for both Microsoft TechNet magazine and the independent Redmond magazine. So let's start by talking about physical storage, because this really plays into pretty much everything that SQL Server does. On disk, SQL Server data is broken down into 8 kilobyte chunks called pages. Now, with very few exceptions, all of the data for every single table row has to fit within a single page. Now, those exceptions tend to be large chunks of data, where your main page actually just contains a pointer, and the data is then spread out across multiple 8 kilobyte chunks called pages. The key thing to remember there is that absolutely every little bit of data manipulation that happens in SQL Server happens in those 8 kilobyte chunks. That really plays a crucial role both in maintenance and performance. It's okay to have more than one row on a single page if it happens to fit. And any index data is also stored in those 8 kilobyte pages. So whenever SQL Server needs to read some data from the disk, or when it needs to save some changed data back to disk, it does so one page at a time, and always in those little 8 kilobyte chunks. Now, when SQL Server does need to actually make some change to data, the first thing it does is it finds the necessary page. So it queries, it looks up whatever page is about to be modified, reads it off of disk, loads it into memory, and then makes the change to it. But that page is not immediately written back out to disk. After all, SQL Server knows that there might be some more changes coming, and if it's going to be a change to that same page, then it's faster to keep it in memory for a little while rather than continually writing it back and forth to disk. It's also possible that the disk system is a little busy right now and doesn't have time to immediately write that page back to disk. So it sits and stored in a section of memory called the cache, which is the largest portion of memory that SQL Server sets aside for this caching purpose. However, keeping that information in memory does put the data at risk. If SQL Server were to crash, or if the entire server were to crash, then you would lose that change. So SQL Server also uses a separate file called a transaction log, and that's designed to keep track of all the changes that it's made and to keep track of which of those have been safely written out to disk. That transaction log, you can kind of think of it as a sign-in log. Every single query that's executed against a SQL Server gets written, I mean like the literal text of it gets written into this log. So this entire model of how things are loaded into memory, logged in the transaction log, eventually written back out to disk, all of this is at the heart of how SQL Server operates. In order for any changes to be made to any data, they pretty much have to go through this process. So just a quick little visual here so you can kind of get this in mind. As SQL Server needs to make changes, these pages are loaded off of disk, they're loaded into memory, and you can see the changes themselves, the little purple hex there and the blue triangle are loaded into the transaction log. They're saved there. And as the information is written back to disk, the transaction log is checked off. So pages are always written back to disk in the same order that they were modified. So essentially, the oldest change sitting in memory will always be written back to disk first, so that as things are checked off in the transaction log, they can be checked off in order. So you will always have a series of checkpointed transactions, they're called, followed by one or more transactions that have yet to be checkpointed. So every single time SQL Server starts, even if you shut down the server normally and you start it up normally, it automatically looks at the transaction log for every single database to see if there are any unsaved or uncheckpointed transactions. If there are, it means that that information was changed in memory but never saved back to disk. So it immediately repeats those transactions in a process called replaying them, which basically just recreates that original change. So a busy SQL Server that has shut down unexpectedly might have many transactions that have not yet been checkpointed, and so restarting that SQL Server can take some time because the first thing it wants to do is start immediately replaying those transactions to bring all of the database files up to current. But what that means is, if you're careful at protecting your transaction log, you can recreate you can survive just about any kind of crash because the transaction log will let you replay or repeat all of those transactions. So because it actually stores the literal queries that have been executed, it's kind of like a script of what's been done recently. Protecting the transaction log is a crucial part of protecting SQL Server and is a crucial part of SQL Server performance and maintenance. Now, that transaction log will fill up over time as more and more changes come in, more and more things go into the log, and there's no automatic process to empty it out. So what you have to do is occasionally make a backup of your database files. When you do that, you know that you then have those safely stored off somewhere else. That's the whole point of a backup. And so it's then safe to truncate or clear the log. And that will remove all of the transactions that are checkpointed and have been safely written to disk and are therefore in your backup. So periodically clearing the transaction log is how you free up more space in the log so that SQL Server can continue operating. Now, if you don't occasionally truncate the log, if you don't occasionally clear it out, and the log file fills up, then SQL Server will stop working. It will stop accepting changes to that database because it can't make any changes unless it's got that transaction log. Most folks will set their transaction log file to grow automatically so that if it does fill up, the operating system can give a little bit more disk space to SQL Server to make room for more transactions. But that'll only last until you run out of physical disk space. Eventually, it will take over all the space in the world. It will fill up, and you'll start to not be able to use your database anymore. So this truncating is a really important thing to do. Now, in addition to backing up your database files, you can also back up the transaction log itself. It's a very fast operation, and that helps to ensure that that very valuable data is available in case it's needed for recovery. So that even if the transaction log itself becomes corrupted or the disks on which it sits crash and you lose the data, you still have a backup of the transaction log. So just really quickly, let me switch over to my virtual machine here. You can see I've got some databases and I'm just going to right-click this database, go to the Tasks menu, select Backup, and then on the dialog box that comes up, I can decide what type of backup I want to do. SQL Server allows me to do a full backup, which grabs the entire database, a differential backup, which will grab everything since the last full backup, or that transaction log backup, which again is a very, very quick operation. There's also something called a copy-only backup. That allows you to do a backup without resetting the pointer. So if you were to do a full backup and then a couple differentials and then a copy, your next differential would still point back to that first full backup. The copy doesn't interrupt that phase. So that's how you can go in and do or schedule a transaction log backup. So let's talk about something else when we come into maintenance here, and it's called index page splits. Actually, I want to take a quick question from Mike. Is it a valid or best practice, Mike asks, to truncate the transaction log every time a valid backup is performed? And absolutely yes. In fact, in that dialog box, it makes it very easy by giving you a checkbox to also truncate the transaction log. Now, if you're doing your backups through scheduled scripts, meaning you're kind of issuing the backup commands in the Transact SQL language, then it's a separate command you need to run to do the truncation. It's not something that happens automatically, but the GUI can shortcut that for you. And I'll show you in a little bit how you can also kind of let SQL Server automate much of that process. So let's talk something about how indexes work. Now, like database data, all of your SQL Server indexes are stored in 8 kilobyte pages. As you add data to your table, those pages naturally fill up. The thing with the indexes, though, is that SQL Server needs to keep the data on those pages in order. So whatever sort order you specified when you created the index. For example, if it was an index on something like a customer name, then you would probably have it sort alphabetically. So as the page fills up and SQL Server needs to insert data into the middle of a full page, it has to split the page. Now that makes up new room for new entries, but it does result in the index pages being out of order or fragmented. Here's what that looks like. This is an index that's sorted by alphabetically. It's sorted, A, B, C, E, and so forth. It's got 4 pages, and 2 of those pages, the first 2, are completely full of data. So when SQL Server needs to add D, it needs to add it to the bottom of the first page. That keeps the data in sequence. In order to do that, it creates a new page, splitting the first page and moving some of the data from the first page to the new page. Now that frees up some space on the first page so that the new data can be saved into it. Unfortunately, that means the index pages are now out of order. So when SQL goes to physically read this information, it has to start at the first page, jump all the way over to the 4th page, then jump all the way back to the 2nd page, and then it can continue sequentially reading the 3rd page. That actually slows SQL Server down, and eventually that can pretty much decimate your performance. Now keep in mind these are in 8 kilobyte pages, and Jeffrey asks, having mentioned those 8 kilobyte pages, is there a suggested block size to format your drive as? And yeah, anything basically that divides evenly by 8. And since that's just one of the binary numbers, pretty much anything will work just fine. It's probably not possible to come up with a number that isn't going to be an even 8 kilobyte page in some number of chunks. I think a lot of people tend to work in half kilobyte or kilobyte chunks. There are some other things that you might be doing on your server that would drive that a little bit more than SQL Server would. So let's get back to indexes for just a moment and talk about what you need to do periodically to your indexes to keep that performance from becoming a problem. You really have 2 options. The first is to rebuild your index. That basically means dropping the entire index and building it over again. And when you do that, you can specify how much empty space to leave on those pages. It's called the fill factor to accommodate future growth. Now there's an upside and a downside to fill factor. If you specify a very low fill factor, then your pages will be mostly empty to start with in the new index. That leaves lots of room for new data to be added without having to split the pages. On the other hand, it will slow SQL Server down initially because it still has to read the entire 8 kilobyte page even though you've set most of it to be empty. So in order to read through the entire index, SQL Server winds up having to read a lot more pages. On the other hand, you could specify a very high fill factor, which means the new index pages will be mostly full with very little empty space. That will make SQL Server perform better initially because it will be able to read more data with fewer reads, but you will run out of space more quickly, meaning SQL Server will get back to fragmenting and doing page splits. The right answer for you is going to depend on how each individual index is actually used. If you have indexes on tables that don't have a lot of new data added to them very frequently, well, then you can specify a high fill factor and get better performance. What I tend to do is this. There's kind of a number that says if your index is 30% or more fragmented, and you can look in the SQL Server GUI, it will tell you how fragmented your index is. If it's 30% or more fragmented, then you want to rebuild it. If it's less than 30% fragmented, you can reorganize it instead. Now, reorganizing doesn't drop the index, it just rearranges the pages and puts them back into order. It doesn't free up any new space. You're not specifying a new fill factor here. Reorganizing is much faster, but it doesn't tend to free up space as much. You could easily wind up incurring page splits almost immediately, depending on the condition of the pages. Reorganizing can be done online, meaning the index can continue to be used while the reorganization is happening. And in fact, you can stop the reorganization and start it up later, and it will pick up where it left off. So my kind of rule is this. If you've got a maintenance window when you know you want to rebuild your index pages, let's say you decide to do it on the weekend, on a Saturday or a Sunday, I want to set my fill factor so that I don't get more than 30% fragmented by the weekend. So if I'm rebuilding my index on Sunday as part of a standard maintenance routine, I want to specify a low enough fill factor that by the next Saturday, so after a whole week has gone by, my index is just at or below 30% fragmentation. Because right then I'm going to rebuild it and the fragmentation will go down to 0 or close to it. And there's really no way to determine what that is except to play with it over the course of several weeks. You know, I'll set it to a particular number and then I'll wait till the week goes by and I'll say, yeah, you know, I only got to 15%. I could probably specify a slightly higher fill factor, speed up performance, and still not hit that 30% number until I get to the end of the week. Now, in newer versions of SQL Server, you can also rebuild your index online. Basically, what SQL Server does is it builds a brand new index in the background, and then when it's ready, it quickly swaps it out for the old one and then deletes the old one. That does incur a performance hit. So you kind of have to judge how that's going to work depending on the size of your indexes and the size of your data. But again, that's something you can kind of play with until you get a feel for it. So let's talk a little bit about backups. Every database is configured to use a specific recovery model. And I want to flip back over to my SQL Server real quick so I can show you where you can look at that. I'm going to right-click the database, select Properties, and then on the Options tab, you can see that I'm using the full recovery model. The full recovery model is the one that uses the transaction log in the way I described earlier. There's a couple of other options you can go with, though. The simple recovery means the transaction logs are truncated regularly, automatically by SQL Server. And that means you can't really rely on the transaction log as a recovery mechanism. So you need to ensure that you get a regular full backup of your data. You might use this on a database that's read-only or a database that contains data that could be easily rebuilt from elsewhere. So if you lose it, it's not a big deal. Full recovery is the one I pointed out. And if you're backing up those transaction logs, you need to know that every single transaction log entry is actually time-stamped. So that means you can actually restore your database to any given point in time. The last option is bulk logged. It sits somewhere in between simple and full, and it means that certain bulk load operations are logged as a single entry, and that speeds those up, but it means they're not recoverable. Typically what you'll do is if you need to bulk load data into a database, You'll temporarily switch to the bulk logged model, load your data, so that'll go very quickly, switch back to the full recovery model, and then immediately take a backup of the database so that you capture all of that data. Now, in terms of backup, Vern asks, what account is used for the backup? Can the password on that account be changed and so forth? It depends. If I'm logged into the graphical user interface and I run a backup, it's running under my credentials. If you run it under a scheduled SQL Server agent task, which I'm going to show you in a little bit, it runs under whatever service account SQL Server agent is configured to use, and so you obviously can manage that password. Vern also asks, which version of SQL Server allows an online rebuild? I know the latest version does, SQL Server 2012, and SQL Server 2008 R2 does as well. I'm not sure how far back that functionality went. I kind of forget in my head when they added that particular piece of information. Mike asks that, I'm assuming the online rebuild you mentioned is in SQL Server 2012, and yes, it is. Are there any other performance and maintenance benefits with SQL Server 2012? And yes, there certainly are. Probably more than we're really going to go into here, but Microsoft does a really good job of adding features and functionality as it goes. And so that's definitely something that you can look into on the SQL Server website if you'd like. Okay, so backups. I mentioned before that you've really got a couple of different types. Incremental is not something that's built into SQL Server natively, although I know most people rely on third-party backup utilities, and so incremental may be an option if you're using something else. So you've got a full backup, which could just be the entire database. It could be just a specific set of files or a file group if you've spread your database across multiple files. You have a differential, which is just what's been changed since the last backup, and the log file backup, and that's what we talked about before. So how might you do this? Well, I've got customers who typically try to get a full backup once a week, if not more frequently if they can, and it depends on the size of the database. Backups don't require you to take the database offline. You can do a SQL Server backup while the database is in use. It just reduces the performance of the database slightly. So you still want to do it kind of during off hours, but it doesn't mean you need to make the database completely unavailable to your users. So they'll try and get a full backup once a week, maybe more often if they can do that. At least once a day, they'll try to get a differential backup. And then, as often as every 10 or 15 minutes, I have customers who'll take a transaction log backup, because it does happen so quickly that it doesn't create a lingering performance impact. And by having that transaction log backup, you can pretty much be assured you're not going to lose any data if something goes horribly wrong. The transaction logs do need to be truncated periodically, and in the simple recovery model that happens automatically, but in the full or bulk log recovery models you have to do that yourself. Truncating does remove all your checkpointed transactions, so that's all the ones that have been written to the database file on disk, and you should only truncate the back after backing up the entire database file. That way you no longer need the transaction log as a recovery mechanism because you have the backup. And to kind of take the other perspective on that, every time you back up the database, you should truncate the log. So the restore process, what happens if something does go wrong and you need to recover? Start with your most recent full backup. Then apply the most recent differential, or if you're using something else, you would apply all of the incrementals since that full backup. Then you apply the transaction log backups that have been made since the most differential or incremental up to your desired point in time, and then you actually tell SQL Server, I'm done restoring files now. I've given you everything I need to give you. Go ahead and incorporate the backups and start replaying those transaction logs to bring the database up to date. When you do that, the database will shift into a restoring mode, which means it will be unavailable to users until it is finished restoring. And if you're using the GUI to do that, get little progress bars and everything else that you can watch so you can kind of track the progress of that. So real quickly, I'll show you where that's accomplished in the product. Let's get out of this database options. You would right-click the database, under Tasks, select Restore, and you would either restore individual files or an entire file group. You can actually restore individual pages or typically a database. And here's where you would simply specify in here all the backup sets you want to restore. So you would pick those, specify which files you want. You can specify options, like let's let it get over the files list here. You can specify options like what point in time you want to bring it back up to. It's having problems listing all the files because I probably have a whole bunch on here. This is the machine I play with a lot. We'll let it do that in the background. I also, while we're in here, want to take an opportunity to show you where that index maintenance occurs. That would be under any of your tables. You've got tables, which is what this catalog is, and then they each have an index, and then each of these can potentially be rebuilt or reorganized. And if you look at the properties for these, you can see that some of the options I have are to specify the fill factor. So you can actually designate a fill factor as a property of the index, and then every time you rebuild it, it will rebuild with that designated fill factor. Now, if you needed to rebuild an index with a different one and you didn't want to dive through the GUI there and do it, you could do it using the Transact SQL language. And in fact, that's what a lot of people do, just because it's easier to do a bunch of indexes that way rather than having to go through here and individually click each one. If you do need to restore something less than a full database, and you saw where I could select that in the GUI there, you can restore an individual file, or if you've got a bunch of files that have been organized into file groups, you can restore an entire file group. You can even get down to the individual 8 kilobyte pages within a file. And there's also something called a piecemeal restore, which means you start by restoring the primary file group, if you have one, and then move on to any secondary file groups. So you're restoring them in chunks. That strategy gets fairly complicated. It's definitely something that requires a lot of upfront planning if you're going to be doing bunches of different files that are backed up at different times, so they might not represent a consistent set of data, and you have to kind of get into these weird little situations. Definitely something to research if you have a gigantic database and it needs to be broken into multiple files, but you want to stay away from it if you can, because it kind of makes your entire life pretty complicated. So before we get on to Q&A, actually, there's a few more things I want to show you in the product. And the first of those is how to make a lot of this maintenance a lot easier on yourself. I'm actually going to close my databases section here and go into my SQL Server agent. I'm going to check the properties on my agent. It does look from the icon like that's started. It is set to auto restart and everything else. So this is just a Windows background service. You can set it to run under any account you want to. There are some specific permissions and privileges it needs. If you set that account up as you're installing SQL Server, the installer will make sure that the account has all the right permissions and privileges. If you're not sure if that's been done, or you know it's not been done and you need to fix it, you can rerun the installer to modify this instance and have it do that for you. So that's the way most people will make sure that that account has everything it needs. Now here under my Management tab, I've got a section called Maintenance Plans. So I'm going to right-click and create a new maintenance plan using the wizard. If you're going to use SQL Server's native backup and restore capability, this is a great way to schedule a backup to happen automatically. And even if you're not going to use the native backup and restore functionality, this wizard is a great way to automate the other maintenance things that you might need to perform on a regular basis. So the first thing we do is name this plan. We need to decide who we're going to run it as, and I've got the SQL Server agent service account selected. If your server has been configured with other credentials, and there is a section where you can just create other credentials, then you would be able to select one of those credentials here. So I'm going to have a single schedule planned for the entire thing. So let's just decide when we're going to run this. We'll say let's run it weekly on Sunday night at 12 a.m. That's the default, and that works for me. Next, we can decide what we want to do. You should always run a database integrity check. This is just going to make sure that the individual pages within the database file are consistent, that they all have the right pointers, and that everything works together. If for some reason there's a problem, then the maintenance task history would alert you to that and give you some options for what to do. There's a couple of different commands you can run to fix those consistency problems. I tend to not shrink the database. What that does is it attempts to move all of the database pages together and then give any free space back to the operating system. I don't like to do that. If I've got some extra space in my database file, I assume it's eventually going to be filled up with data, and so I'll just keep it for myself. You can choose to reorganize indexes or rebuild indexes, and we'll get to select those in a moment. Updating statistics is a great thing to do. Think of statistics as kind of like a traffic report. If I ask you what path you're going to take or what route you're going to take to get from your house to work in the morning, you might say, well, I don't know, what's traffic like at that exact time of day? And that's a great question, because without that information, you might get up on the highway and find yourself in bumper-to-bumper traffic. That'd be a bad idea and slow down your personal performance. Well, statistics keep track of the condition of your indexes, along with a few other things, and they tell SQL Server which indexes are in good shape and which ones aren't. It's a traffic report. Without good statistics, SQL Server won't make good performance decisions when it comes time to execute queries. So updating these statistics on a regular basis is a great idea. We can clean up some SQL Server agent job history if we've been doing such a thing. I don't have a specific job I need to execute. We can run backups of our databases, and we can clean up the history of the maintenance task itself. So here we go. We can decide what order we want these to go in, and the default order is pretty good. Check the database integrity, do a rebuild, and we always want to do a rebuild before updating statistics because the statistics will be better after the rebuild than beforehand. Let's do the database backup first, and then we can do all of our cleanup tasks. So now we get to decide what databases we want to do this with. I'm just going to pick my report server database. Oh, and you'll notice that the little checkbox there includes indexes, so I'm going to back those up as well. So now for the index rebuild task, what are we going to do? Well, I'm going to pick that same database because I want to rebuild its indexes. And because this is happening at Sunday at midnight, we are just going to build all indexes on all tables and all views. Now, I'm not going to change my free space. This is where you can set the fill factor. I don't like to set a global fill factor because different indexes get used in different ways. I would rather go and specify an individual fill factor for each index, which I showed you how to do in the index properties already, and let that be used. So we'll do that. I do want to keep the index online while re-indexing. And for an index type that doesn't support online rebuilds, I'll go ahead and rebuild it offline so that everything does get rebuilt. What are we going to update statistics on? We'll make it that same database. We'll update all statistics by doing a full scan. Now we'll do our database backup. I want to back up report server, and I want to do, well, let's back up the entire database. We won't set the backup set to expire. I am going to need to add a file here, or I can create a backup file for every database, which is fine. We'll break those into subdirectories, keeps them a little easier to manage, and we'll have it verify the backup when it's finished. Let's go ahead. I'm not sure what the default is, but let's go ahead and compress the backup to save a little bit of disk space. And that's the full backup already. We specified that. Now we can define what history we want to clean up. We'll clean up all the history. Anything older than 4 weeks, we'll have it get rid of. And now we'll do our maintenance cleanup. So let's delete any of our old backup files, anything older than 4 weeks. And we'll write a report. And if you've set up SQL Server Database email, then you can also have it email that report to you, which is very convenient. And that should be it. So this will go and create the plan for us. It's not actually performing any of those tasks right now. It just created the plan, which we can now see right here. And if you ever decide you want to change it, you can just click Modify and essentially kind of walk through the whole thing again. Now you can see here, this is sort of the full view of a maintenance plan. It looks a little bit like a Visio diagram rather than running through a wizard. But you can see each of the major tasks we've selected, and then double-click on one of these to update any of its options or settings. So you do get quite a lot of functionality, and this maintenance plan is an easy, kind of all-in-one way to make sure that you're getting all your maintenance tasks out of the way and that they're happening on a regular basis. So those are some of the essentials of maintaining SQL Server performance and fundamentals, and I'd certainly love to answer any other questions that you've got. So feel free to drop those into the question and answer queue, and we've got a few in here right now. Vern says, I thought the log truncation was a function of the full backup process. Is it a separate step? It actually is a separate step. If you're doing a full backup through the GUI, there's a checkbox, and so the GUI will do both of those steps for you. But if you're not doing it through the GUI, if you're scripting it say in T-SQL, then it actually is a separate step. Mike asks, is there a one-to-one ratio of transaction logs to databases? Typically, yes, there is. There usually is a one-to-one. Not necessarily, because you can have some databases that are set to simple recovery, although even in simple recovery, they do have a transaction log. It just gets cleared. So yeah, I guess it's fair to say there's a one-to-one ratio. How do you look at every index, as there appear to be many? Yeah, there are. And that's one thing that I can't give you a fixed answer for, because Microsoft has changed the command you run through almost every version of SQL Server. But if you get into Books Online for your version of SQL Server, there is a very straightforward command in every version that you can run that will show you every index, how big it is, how much free space is in it, and a percentage of how fragmented it is. So there absolutely is a way to do that. You're just going to need to dig into SQL Server's Books Online a little bit to find that. Is there a way to test the SQL service account for the proper permissions, or to know if the password needs updating? I don't know that there's a way to test it for the proper permissions. If SQL Server is starting, then it probably has the proper permissions. And in terms of knowing if the password needs updating, neither SQL Server nor the service actually controls that password. If you're using a domain account, then Active Directory determines when the password needs to be changed. My recommendation, particularly if you're running SQL Server on newer versions of Windows, say Windows Server 2008 R2 and later, is to look into Active Directory's Managed Service Account feature. Essentially what that means is you set up an account in Active Directory, much like a normal account, and you set an initial password. Then you go to your service and you configure it to use that account and that password, and from then on, the service and Active Directory will work together to change the password, so you'll never have to mess with it again. Thomas asks, I'm newer to SQL and I'd like to practice disaster recovery in a VM before I get into production. Microsoft has free databases, but does MS add data that you can have data you can add to the DB so that you can practice disaster recovery without having to manually enter data? I don't actually know if they do or not, but I'll tell you where you can try and get a good set. If you get onto their training and certification website and you look at some of the Microsoft official curriculum, there are practice files you can download. And those not only include some of the practice databases, but also some scripts that dump a lot of data into there, and that's really what you're after. Mike asks, on the items that you covered, are there any different concerns when you use SQL Server as a data warehouse versus online transaction processing types of transactions? Pretty much everything we've covered still applies. In an OLTP database, you may find yourself running in bulk logged more frequently because that's kind of how those databases work, and you will have a lot more indexes, but the basic tasks are kind of all the same. Renee says, how often do you need to schedule the index rebuild? Well, that's going to depend on how quickly your indexes become fragmented. You're going to need to look at them. Now, as I said, I like to get those things as organized as possible, so if I have the time and if it doesn't take too long, I'll run a reorganization every night. But that won't completely stop page splits and fragmentation from happening. What you want to look for is run the command to look at the index fragmentation. You'll need to look in Books Online to find that command because it does differ from version to version in SQL Server. Once your indexes are hitting 30% fragmentation, it's time to rebuild. So keep track, look at it, once a day for a couple of weeks, figure out how long it takes them to get to that 30% fragmentation level, and that kind of tells you how often you'll need to rebuild them. You can extend that time by rebuilding them with a lower fill factor. And that's one of the reasons I can't give you a fixed answer on how often you need to do it, because you can control that time period by messing with the fill factor a little bit. Brian asks, do you find it necessary to occasionally manually modify the maintenance plan that's created by the wizard? And are those SSIS packages in both SQL Server 2008 and 2012? They are SSIS packages in both of those versions. And do I find it necessary to manually modify them? Pretty rarely, but yeah, sometimes the business will make a decision that we want things to happen at a different time, or we want things done in a different way, and then I'll go in and do that. Is the best place to get troubleshooting help through the Books Online? That is certainly the best place to start. The books online are quite good. The SQL Server has great documentation, and so I would definitely start there. You may find yourself out on the internet after that to dig up more information, but that's always where I start. How critical is it to learn T-SQL, or can most everything be done via the GUI? I don't work on the databases myself. I only need to make sure they're running and maintained properly. You can do pretty much everything through the GUI. And the good news is that in most of the GUI screens, there's a little button that will show you the script or the T-SQL commands that are actually being run under the hood of the GUI, because that's all it's usually doing. And so that's kind of a good way to learn SQL. You should pick it up. You will be a better DBA or database administrator in the long run, but it's not super critical that you do it immediately. Is PowerShell an easier method to manage SQL servers compared to T-SQL? That's from Sean. I would say no. I love PowerShell. I'm a huge fan and one of its biggest cheerleaders, but the implementation for PowerShell in SQL Server that the SQL Server team did is pretty low-level stuff. I find myself, when I'm performing most of my standard routine tasks, still using T-SQL. If SQL Server is using all of the memory in a server, how do you fix that issue? That gets a little complicated. SQL Server is designed to use all of the memory in the server. You can configure some properties of the server, and that can all be done through the GUI, to use less, but you need to be very careful about that because that can significantly impact performance. So you do need to be very, very careful with it. Now that does bring us to the end of the questions that I've got queued up, so I'm going to turn things back over to the friendly folks at TrainSignal to wrap us up.
Well, that's all the time we have today. Thanks again for attending and for your participation. As a reminder, today's webinar was recorded and will be available to view at trainsignal.com/blog/webinars. We will also email you the link by the end of this week. And as a reminder, you leave, please fill out the survey for a chance to win a copy of TrainSignal SQL Server 2008 Administration Video Training. We will email the winner by the end of the week. Thanks again and have a great day.